Welcome back. In this video we're going to be talking about the quadratic formula. So we've talked about already, if we have a quadratic equation, the way you should first attempt to solve it is by factoring. And if factoring is not possible, then you can use completing the square. This is a third method that can be used to solve something that is not factorable. Technically, you can use completing the square and the quadratic formula at any time. They will always work, but they're mainly used when something is not factorable, since factoring would be the quickest method. So it says the quadratic equation written in the form ax squared plus bx plus c equals 0, so the standard form of a quadratic equation, has the solutions x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. You do have to memorize this formula. It would not be provided for you on a test. So there are songs and things like Pop Goes the Weasel. You can find them on YouTube to help you remember this formula. But this will give us the solutions, the x values for this quadratic equation here. Notice that it has to be set equal to 0, and then we can identify a, b, and c to plug into our equation. Looking at this first example, it says 2x squared plus 9x plus 10 equals 0. It's already set equal to 0, so I can right away identify a, b, and c. A is always the term with the x squared, so 2. B is the coefficient to x, 9. And c is the constant, 10. And those are the values I'm going to be plugging into my formula. So x will equal negative b, so minus 9, plus or minus the square root of b squared, so 9 squared, minus 4 times a, which was 2, times c, which was 10, all of that divided by 2 times a, which is 2. So again, you can just see we're plugging in 9 wherever there's a b, 2 wherever there was an a, and 10 wherever there was a c. There's no x's here. We're finding x. Alright, so there shouldn't be any x's or x squareds in this part of the solution. Alright, now we need to simplify. 9 squared is 81, and then 4 times 2 is 8, times 10 is 80. So we'll have 81, I'm looking under here under the radical, we'll have 81 minus 80. So that whole thing under the radical will simplify to the square root of 1, right? 81 minus 80 is 1. In the denominator, 2 times 2 is 4. Now, a lot of times students try to stop there, but it's important to note that the square root of 1 can be simplified. The square root of 1 is 1, so don't leave that under the radical. And now we can simplify into our two solutions that we're going to have, right? So we'll have negative 9 plus 1 divided by 4, or negative 9 minus 1, using that plus and minus, breaking it up, divided by 4. I'm going to go ahead and bring that up here. Negative 9 plus 1 is negative 8, and negative 9 minus 1 is negative 10. And then we have to simplify these fractions. Negative 8 divided by 4 is a whole number, it's negative 2. And negative 10 divided by 4, we can divide out a common factor of 2 and get negative 5 halves. So there are two solutions in general when we use the quadratic formula. The only time that there's not is if the stuff under the radical is 0. And then this whole second half would be 0. So there would be no plus and minus because there's no plus and minus 0. And you'd only have this negative b over 2a part. Alright, so generally you should end up with two equations. If you have radicals, you should simplify your radicals, and don't forget to simplify complex numbers. So square root of -1 is I. Go ahead and try the two examples on the right. Alright, this example here says 2x squared equals 6x plus 1. So it's not currently in the correct form, right? We have to have it set equal to 0. So I'm going to go ahead and move my 6x and 1 over to the left. I just like to keep my leading coefficient positive. So now I have 2x squared minus 6x minus 1 equaling 0. Now it's in the standard form. It's set equal to 0, and we can identify A, B, and C. A is the coefficient to the x squared, 2. B is the coefficient to x, which is -6, and C is our constant of -1. We're going to plug that into our equation. X equals -b. So what do we do if b is already negative? Well, the negative of a negative is positive. So positive 6 plus or minus the square root of b squared, so that's -6 squared, minus 4, a is 2, c is -1, all over 2a. Alright, we're going to simplify what's under that radical. So we still have 6 plus or minus. We'll have -6 squared is 36. And then 4 times 2 is 8. 8 times -1 is -8. So we're subtracting a -8. Or we could think of this as -4 times 2 times -1. Those two negatives are going to make a positive. So we'll have 36 plus 8. And 36 plus 8 is 44. So we'll have the square root of 44 underneath the radical. All over 2 times 2 is 4. This radical is not simplified, but we can simplify it, right? We could factor 44 as 4 times 11, and 4 is our perfect square that can come out of that radical. So I'm going to rewrite this as 6 plus and minus square root of 4 is 2. Still have that square root of 11 underneath the radical. All over 4. And then we notice here that 6, 2, and 4, so all the pieces outside the radical, are even. That means we have a common factor of 2. So this only works if every term has a common factor. So our first term, our radical term, our denominator, they all have to have a common factor before you can divide it out. And since these do, I'm going to divide out 2. 6 divided by 2 is 3. 2 divided by 2 is 1, so we'll just have the square root of 11. And 4 divided by 2 is 2. If your homework makes you, you might have to break that up into the two solutions of 3 plus square root of 11, that's an 11 there, over 2, and 3 minus the square root of 11 over 2. So you can see those two solutions clearly with the plus and the minus. Alright, it said leave exact, so we're not going to do a decimal or anything. We're just going to simplify our radicals as much as possible, but then leave it from there. Alright, this next example here, it's already in our standard form, which is nice. So we can pull out our A, B, and C. A is 3, B is -4, and C is +2. We plug it into our formula. -b, so of negative 4 would be positive 4 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. We're going to simplify what's under the radical. We have negative 4 times negative 4 is a positive 16. And then negative 4 times 3 is negative 12, times 2 is negative 24. So we'll have 16 minus 24. That's going to give us a negative 8 under the radical. And in the denominator, 2 times 3 is 6. Again, our negative 8 can be simplified. 8 is 2 times 4, so we can take out that perfect square. We're going to have a 2 left underneath. And we can take out that negative. So 4 plus and minus the square root of negative 1 is I. Oops, I don't want to do that first. I want to do square root of 4 is 2. And square root of that negative 1 is I. So those are the pieces that can come out. Still underneath the radical is the 2 that didn't have a buddy, all over 6. Again, I noticed that my 3 terms here, 4, 2, and 6, have a common factor of 2. So I can go ahead and divide out a 2 from everything. And x will equal 4 divided by 2 is 2. 2 divided by 2 is 1. So we just have I square root of 2. And 6 divided by 2 is 3. And again, you could break this up into this 2 solutions like we did up here, separating that plus and minus. Pay attention that you might have to write it in the form a plus bi because it is a complex number. So again, just pay attention to the directions of your homework.